Welcome to Earth Science. So let's do igneous rocks first. So again, you're going to need to know what an igneous rock is. If you're going to tell me what the properties are that you see that let you know it's igneous, well, you better know what an igneous rock is, which is a rock that came from melted rock. Other rocks melt into magma. That magma solidifies, turns into an igneous rock. All right, so I got some small samples here, and I got my computer screen of the ones that you saw during the lab. So, reminder, melted rock generally comes closer to Earth's surface one way or another, tectonically. Some of it only makes it part of the way. Those are intrusive. They cool slowly and have a coarse texture, but they still came from magma and lava, right? Some burst out of volcanoes. We call them extrusive, and they have some different textures, and we'll remember those as we do this. But in all cases, those are igneous rocks, right? So we're going to start, I did this in order of easiness over here. So igneous comes from melted rock. This sheet will be uploaded with your Google Classroom. Please check it. The easiest one, I think, on the whole entire lab, the whole entire sheet to see is rocks that are vesicular. That's that one right there. Vesicular means that they have gas pockets. Should you ever forget that, New York State was nice to you and said, hey dude, vesicular means that it has gas pockets. Here's a hand sample of one. And again, pretty easy to see. It's got all these gas pockets. That's what vesicular is, right? If you remember my example of this is like the magma under pressure. When the volcano blows its top, the CO2 comes out of the liquid form, turns into a gas, and creates all these bubbles. You've experienced this most likely if you've ever opened a soda that's been a little bit shaken. That CO2 under pressure wants to get out as fast as possible. Makes all these bubbles, right? Soda foam goes away quickly, but if you could freeze it instantly, it would basically look just like this, maybe slightly different in color. Those are the gas pockets. It's vesicular. So to just like sneak preview on what the lab's going to be, and I promise this one will be there, whether it's that one or this one, I don't know yet. All you'll say then is, okay, Mr. F, that rock is igneous because it's vesicular. If you say sedimentary or metamorphic, that's wrong. I think you know that. If you say igneous because of this interlocking crystal thing that you don't know about yet, that's wrong too. It's got to be the right rock and the right reason. All right? Don't know that guy. Number two that's also fairly easy is the glassy texture. And I did have one here. There we go. And again, there's not much I can say about that. It looks like a lump of glass. It's very unique. Like these first two ones, when I say easy, I mean unique. There's not other rocks in the other categories that really look like these two at all. So they're going to be your gimmies. If you see that, you say, oh, that's igneous because it's glassy. You're all done. Move on. Move on to the next one, which we'll do. The next one, I've got two examples here. Again, both from your lab. We have diorite and granite. Exhibit this thing that's maybe slightly harder. And the word you're going to use is uniform interlocking crystals. All right, so here's what I mean by that. Here's a small piece of granite. I'll try to get it at the right angle for the light here. There we go. So this piece of granite is made up of all these separate individual little minerals, right? These minerals, again, if you understand what an igneous rock is, were liquid. This was hot enough to be a liquid. And as it slowly cooled, forming these large crystals, each one of these, like on an atomic level, bit by bit, atom by atom, molecule by molecule, got larger and larger and larger and larger and larger. And they continued doing that until they were large enough that basically, besides the fact that the magma's all cooled, they're large enough that they're all intertwined with each other, all intermingled with each other, and fit perfectly together. So the only way that this formed like that is if it came from that liquid magma, and therefore exhibits those uniform interlocking crystals, which are kind of like puzzle pieces. So if you wanted to argue, like some people will say, no, Mr. F, that must be sedimentary because I see bits, and those like sedimentary are made from bits that stick together. And I see what you're saying, and I'm glad you're trying to think about it. The trouble is that these bits would have to pre-exist in exactly this shape. So like this black piece would have to pre-exist. This clearish whitish piece would have to pre-exist. And in some random deposit somewhere, they would have had to have landed together perfectly so that that little nub fit exactly into that little black part. like it'd be like shaking up a 1,000-piece puzzle, chucking it on the floor, and hoping that it all comes together perfectly. It's not going to happen. All right, so that is a sign. That's like what we're doing here in this lab, is looking for the signs that are a giveaway for what kind of rock it is. It's igneous. I see these uniform interlocking crystals. I did these kind of bizarro drawings that I do every year. Just as a hint, these are like interlocking crystals. Ignore that if that's too weird for you. Okay, so that'll do it for most of the igneous. Now, we'll tell you where we let you off the hook here at online at home Rare Science. Is we could make it harder by giving you things like basalt. Basalt is like a fine-grained dark rock. It just kind of looks... Do I have some here? There's nothing in this that's like stand... No, that's not basalt. But there's nothing in a basalt that would stand out enough to say, hey... Sorry, I don't have any. To say, hey, here's an indicator that that is igneous. In fact, me making that mistake because I'm looking fast, that was actually sedimentary. Like shale and slate look really similar to that. Or metamorphic, you get over here and slate. So shale over here, slate over here. They all look so similar that there's nothing that you would be able to do to like tell that difference. So the ones we're doing here are the ones that are the features that are unique enough, that stand out enough to be obvious. So we'll get you there. Watch these videos. We'll do 2 more for the other 2. I'm sure you're having fun. And see what the quiz is. Try it a couple times. We'll get you your points. All right. So long from Rare Science.